Hello and welcome back again to crazyrobotics.com. So today I'll show you how we have soldered the rest of the gesture sensor control that I have shown you last time. So in our last video we have gone through just the basic component requirement of what uh, things are required to actually make this gesture controlled task using Arduino Uno. So in this video, as you can see, I have already soldered these 5 flex sensors and I have already measured these with the help of multimeter, and I found that the flat resistance is about 47 kilo ohms. So I have attached approximately 3.3 kilo ohms, or I guess it is 33 kilo ohms. The usual process that we follow while attaching these flex sensors is in a voltage divider fashion. So for instance, if we have to connect a given pin of Arduino to one of these flex sensors, then as you can see, we have very specific representation on the sensor itself. That is, we have a resistive element on this sensor, and there is one common line coming all the way to one of these terminals. So this line, which is a little bit straight on the sensor, is actually the ground terminal. I mean, this is the way how we usually connect, but it's not hard and fast that we have to always connect this to ground. You can consider this particular sensor as simply a piece of resistance, and you can take another resistor as you are able to see here. So I have taken this and this sensor both together connected in series. So as you can see, the other terminal of the resistance is connected to VCC, and that comes all the way to this sensor, so that this becomes the center point of two resistances, I mean the red terminal. And then from here I complete the series through this sensor, and the right side brown terminal goes to the ground. So similarly, I have attached all the rest of the 4 sensors where I have a common point, this one, which is this is my VCC. So this power source is going directly to all the resistors. So as you can see here, I have this strip of 5 wires directly going to these 5 resistances, and these resistances are connecting to one of these terminals on the sensors, and the other terminal of the sensors are going straight away to the ground. And those points where the resistors and the other part of the sensor is connected, those 5 rest of the terminals are directly going to the 5 terminals which are analog pins on our Arduino Nano. So these 5 sensors are connected in such a way so that the common point where VCC through the resistance is connected to one of the terminals, the same terminals on all the sensors, I mean these common point where we have 2 elements connected, one wire and one resistance, and these common points are going straight away to these analog pins on the Arduino Nano. So I have connected these 5 sensors, and I have named them in Arduino program like thumb, pointing, middle, ring, and little. So these are the names of the fingers which I have named to these sensors, so that it would be easy for us to analyze the value of the sensor whenever we are trying to monitor them on the serial monitor. So in a short moment we'll have a look at the program, but in the meanwhile we have one more sensor, that is ADXL335. As you can see, this is an accelerometer which offers an X, Y, and Z axis readings along with two more extra terminals, that is VCC and ground. So as you can see, again I have taken these two terminals as common, that is one is going to be VCC, another is going to be ground. So I have connected VCC of the sensor to the VCC of nano, ground goes to the ground, and X, Y, Z terminals are connected to the remaining analog pins on the Arduino. So as you can see, this is Arduino Nano, which has 8 analog pins. This has 8 analog pins. So we have A0 connected to the thumb sensor, A1 connected to the pointing sensor, A2 connected to the middle sensor, A3 connected to the ring sensor, and A4 connected to the little sensor. So these are the names of the flex sensors, as I have already told you. And the remaining sensors, the remaining analog pins, that is A5, A6, and A7, are connected to the X, Y, Z terminals of this accelerometer. So this is how we connected all the 8 analog pins to all the available 8 analog signals coming into the Arduino sensor, Arduino controller. Now we have also attached HC05 Bluetooth interface kit, and the connections between Arduino Nano and Bluetooth are very simple. So we simply take up the TX pin of Arduino Nano that directly goes to the Bluetooth RX terminal, and the Bluetooth TX terminal goes to the RX of Arduino Nano. But make sure that currently, as you are able to see, I have already soldered it because I have already programmed it, and I'm sure that I'm not going to change it anymore, and I'm going to pack all this entire setup into a hand gloves or something that would be kept as a later assignment. And along with that, I have also attached one DC power plug to one of the extra spare VCC and ground. As you can see, the last pin actually reads as VIN on Arduino Nano. Means this is the pin which can be used for external power supply for this Arduino Nano. So as you can see, this is the entire setup. That is, we have simple HC05 Bluetooth interface kit, through which I'll be sending the readings of all these 5 sensors along with the accelerometer readings onto the cell phone. So for that, we need to simply search for Bluetooth terminal in Android Play Store, and I'm going to click on this, that is Bluetooth terminal HC05. I think it says Mighty IT. So this is the developer. I have already installed it, so I'm going to directly open it and show you how the things happen, and then we can switch to the programming stuff. So as you can see here, I have already paired this HC05 with this one. Here the last third option actually shows that this was already paired, and once I click on this, if this is powered up, then I will be able to directly have a look at the sensors readings onto my cell phone. So let's have a quick look at the code here. So as you can see, I have named these sensors A0, A1, A2, A3, A4, A5, A6 and A7, as I have already shown you, with the 5 flex sensors and the remaining 3 XYZ that belongs to the accelerometer. Now as usual, we have 2 things available in any Arduino code. The first function is setup, where we do all one-time activities like initializing the serial ports or defining the pin modes and rest of the stuff. So here I have defined pin number 13 as output, but we haven't used it in our practical setup, as you can see. And here, if you observe, we have initiated a Bluetooth serial port with a baud rate of 9600, as well as I have initiated the default serial port on Arduino Nano with the same baud rate again, that is 9600. So whenever you are interfacing 2 serial devices, like maybe you want to send the data or you want to interface multiple serial devices, like currently I'm using only one Bluetooth chip. Along with this, if you have some another kit which works on the same UART port, you need to occupy few more RX and TX terminals, then Arduino offers something known as software serial. So by using a third-party library called software serial, you can literally define any digital pin to act as a serial port. So I just don't want it to connect this serial port to any of these pins. So what I have done is I have straight away connected the RX and TX terminals to this Arduino Nano. So as I told you earlier, that whenever you are trying to program Arduino Nano, your Arduino RX and TX pin, especially the RX pin, needs to be kept floating. So in case, as you can see here, I have already soldered Bluetooth chip with the Arduino Nano, and now if I try to program this, I will be getting an error, or it will just stay with the status of uploading, and it will never ever upload. So here we have one simple concept, that is, if you don't want to use, or if you want to keep your Arduino programmable, then we have to use any other port different than the default RX and TX terminals on our Arduino Nano. For that sake, I have defined pin number 2 and 3, which I should be connecting to the Bluetooth RX and TX, but since I have already programmed it, I neglected that, and I have directly soldered them onto the RX and TX port. So if you are replicating the same project for your own purpose, then you can connect Bluetooth RX and TX to digital pin number 2 and 3. So that's the job of this particular line. Similarly, we have another function called loop, where we do all that stuff which needs to be iterated again and again while the Arduino or the system that we are actually trying to build. So here, as you can see, we are simply checking whether there is any serial content available on the serial port, that is the Bluetooth port number, digital pin numbers 2 and 3, and if there is something, then we are going to read it and straight away write to the default port. That's what this simple loop talks about. Next, we have a simple logic that we are building here, that is, I have taken a variable. As you can see, thumb is an integer variable. I have simply loaded that integer variable with the analog reading on one of the analog pins. So the same process is replicated for all the rest of the sensors, including the accelerometer readings. So as you can see, we have written the same statement again and again. Now we are simply reading one of the analog pins by using the default Arduino function called analog read, and then we are loading that entire value into one of the desired integer variables, which are sensor specific. So as we are already aware that A0 is connected to the thumb named flex sensor, so whatever I read on port number 0 would be corresponding to the thumb sensor, the thumb flex sensors. So once we read it, I'm simply I'm simply forwarding the same data onto the serial port. So once this is all done, you need to be careful that you are choosing the right Arduino board under the tools section. So here the Nano that I'm using currently has an old bootloader. So for instance, if you are selecting this as Atmega 328, if you have a new bootloader, if you have purchased it recently, then probably this will work. But if it doesn't work, or if it is showing you any sort of error, then you can always go and select this old bootloader and everything will work fine. So along with that, so as you can see here, currently nothing is connected, so it is not showing me the COM port. Let me connect this stuff to the laptop, and then I'll show you how it works. Okay, so as you can see, things have powered up. This is trying to pair. Now as you can see, COM port is by default detected. It is on COM number 11. If I try to click on upload button, it won't upload because I have my Bluetooth chip already soldered onto my Arduino board. So let me have a close-up and show you. If I tap on this HC05, it opens up a Bluetooth terminal, and as you can see here, the readings are forwarded or updated after every 1 second, which is what we have written in our code. So as you can see, currently I have X, which is reading something around less than 400. So if I tilt it upwards, you can see that X value is now 431. So similarly, we have Y axis currently less than 400. If you tilt it towards your left, it is going to be less than 300. If you tilt it towards right, it is going to be more than 400. It may reach beyond 600. It depends on what kind of tilt or angle you are actually providing to the accelerometer. Similarly, for this Z direction, if you take it towards you, is going to fall below 400, and if you take it upwards, that is on the positive side, it is going to exceed more than 400. So this shows that how the readings are being captured through our Arduino Nano, and the same readings are forwarded further to Bluetooth chip, which is transferring the data onto your Android app. And this is how it reads. Now let's have a look at the code. If I go ahead and click on the serial monitor here also you have look at the same stuff. So as you can see, parallelly we have the same readings available on both the things, whether it be the cell phone or whether it be the serial monitor that you're able to see, which is on my laptop. So once this all setup is ready, now we are good to go with, let me change the focus. Once we're all set with the data logging device, so which is going to be the cell phone in our case, so let me keep it aside and let me disconnect this. So now you're ready to place this entire setup into any gloves, something like this. You can stitch this and you can enclose these three devices into a small package along with some USB power bank, or you can externally source this with any battery source which your Arduino Nano supports. So I suppose you can give any voltage somewhere in the range of 16 to 9 volts, which would be considered safe for providing this Arduino Nano with an external power supply. So this application can be used to trigger any home appliances depending upon what exactly you want to perform. So on the other hand, since we are having a cell phone, you can use any third-party applications to trigger any sort of home appliance, or you can even control a small robot, so that depending upon these 5 combinations, you can have numerous amount of sub combinations which can be related and be considered for taking an appropriate action if you are controlling a robot or you want to control a home device. So depending upon what your desired application is, you can decide whether to go with this Bluetooth chip or not. Otherwise, you can straight away throw some action signals onto the digital pins of your Arduino so as to control the devices. So that's all about building a gesture control using Arduino Nano. So that's all for part 2. Stay tuned for the upcoming videos.